All right, welcome back, nerds. As everybody knows and expected, all right, it's Bow Tie Tuesday. Okay, so of course I dressed up. All right, gotta keep the same mental professional mindset since I'm such a professional person and educator. I take my job very seriously. So here we are. I expect that all of you at home are also at bare minimum, dressed up, business casual. It would be ideal if you were wearing bow ties too. So make sure you're doing that if at all possible, especially on Bow Tie Tuesday. We're trying to create a sense of community here. So I expect full participation from all of you. Cool. Great. All right. Hopefully things got your bow tie on. Great. Love it. So I hope things have been going well. Regular tie is not bad. Right, bow tie is ideal. So maybe just kind of tie it in a bow tie-ish type shape. It'll be really comically large, but sometimes we have to make sacrifices, and if that sacrifice is doing that in order to have a bow tie on, then I think it's well worth it. I think everybody would agree with me on that too. So we're good to go. Back to our logarithm stuff. So we talked about kind of some general logarithm properties yesterday. We're gonna stick with that today and then do some solving logarithmic equations. All right, it really won't be probably be a relatively short class, or I doubt we'll go the full time or near it. But then we can finally delve into our last like application and word problems, which I really enjoy and are pretty interesting. So we'll just kind of practice solving some equations today so that we can then use that in our next few days of lessons. Good deal. So since you're all wonderful students, right, then I know that due to the fact that I emailed this to you, I don't know, 4 or 5 hours ago, that you have already opened this file and have already attempted the warm-up, right? That is the ideal world that we live in, that whenever I start up the stream, you've already attempted the warm-up beforehand, since I'm not going to sit here and like pause and wait and say, everybody in chat, do the warm-up. So ideally, just beforehand, sometime in the 4 to 5 hours throughout this day, before I start streaming from when I email it to you, open it up and give the warm-up a try, just so you can try something on your own and then compare with me whenever we go through and do it. But again, I know you guys already did that because you're such good students. Sally cooks a lot. Okay. All right. See, I said that about being good students, and now you're coming in saying these uncultured pronunciations of Sally's name, and it's disrespectful. Unacceptable, Finley. Not cool. Not cool at all. I try to compliment you guys, and this is what I get repaid in. Band, yeah, the mods will take care of it. There we go. Those are some better interpretations of the name. I like it. Okay, so for number one, expanding logarithm. So again, what that means is we want to take this logarithm and split it up as much as we can using as many of our properties that we can. So before we do that, though, we're first going to look at the inside, and I notice that I have these z's, the numerator and denominator, that I can simplify. So I know that z to the 12th divided by z to the 4th is z to the 8th. So just a quick simplification before I do anything else. And actually, I'm going to go ahead and do one more thing as well. I might as well do it here. We talked about yesterday, instead of writing the root symbol, okay, let's write it as an exponent. So the sixth root of y would be the same thing as y to the 1/6 power. That's not too pretty. We'll fix that. Yeah, y to the 1/6 power. So I'll go ahead and do that up here. Might as well. You can save it for later on, but it doesn't matter. Okay. Now, first things first, let's address the division. That's your best bet when you're expanding. First, worry about the division. So I know that whenever division takes place inside of the logarithm, then when I can split it up into two logarithms. So the numerator is what goes inside the first logarithm. And then they are separated by subtraction. Log base 3 of the denominator. Right, so numerator goes in the first log, denominator goes inside the second log. Now I need to split up this second logarithm because I see that I have x cubed and y to the 1/6 power that are being multiplied inside there. I'm getting a phone call because I'm so popular. I have a lot of friends. See, look, they're calling me right now. No, I can't come to the party of 1,000 people. That's not safe at this time, but I do have that many friends, so I could if I wanted to. Yes, thank you. No, it's not an alarm. Okay, it's a phone. It's ringing. Look, slide to answer. Okay, you could do it. 1,000 spiders. No, that's not. That wasn't a story about me. What? I don't know. You guys take things way out of context. I don't know where you get these crazy ideas from, but it's, you know, your imaginations are running wild. Maybe by being cooped up for so long. We're on day 11 here since our last day of school, and it seems like you guys are going wild. All right, so my second one, I'm going to split up. Now, remember we talked about, since this is a minus sign, when I split this up afterwards, I need to be really careful. I need to make sure to put all this stuff inside parentheses or brackets. So the multiplication that's going on inside this logarithm will get split up with addition between the two logarithms now. And I'll finish my brackets, not 7. Brackets. Right. Make sure you have that around because we are going to need to distribute that to whatever is inside of these brackets or parentheses. So I'm going to distribute that. Also in this last step, I'm going to take all of my exponents and move them down in front as coefficients. So 8 log 3 of z minus 3 log 3 of x, not plus, sorry, minus 1/6 log 3 of y. What if it's a spider helping Mr. Punish you? Just don't look too closely at my hair. You know, there's a reason that I have to wear it up like this, but just let me see. Let me kind of step back a little bit. So here's my final expanded logarithm for, or logarithms. Right? So the trickiest thing is just remembering that minus sign that gets distributed. Number 2, change the logarithm to base 2. So we're going to use our change of base formula. This is another application that we can use it for, because one thing we can just use change of base formula to calculate, like in a calculator, and make it more easy. But also sometimes we can make it easier on ourselves. So I'm going to change it to base 2. All right, so I know my change of base formula is the log of whatever's inside goes on top, so 32. And the log, whatever was the original base, then goes inside in the denominator. And since I said base 2, that's why I chose base 2 here. Okay, I could have chosen any number there. I could say change it to base 1,000 or change it to base 13 or whatever. I just chose 2 here. But I chose 2 specifically for a reason, because we can evaluate both of these logarithms easily. All right, so I look at my denominator, log base 2 of 4. Remember, logarithm just means what exponent will we need to get from 2 to 4? Well, 2 squared is 4, so 2 in the denominator. And then in the numerator, what exponent do we need to get from 2 to 32? Right? Well, 2 to the 5th power is 32, so this just equals 5/2. And so it's kind of another use that we can have for the change of base formula, rather than just, I mean, it is usually helpful for just helping us type things in on a calculator that we can figure it out. But also sometimes if I notice, well, 4 and 32, I don't know what, 4 to what power makes 32? I don't know that off the top of my head. But 4 I know is a power of 2, and 32 is also a power of 2. So I could rewrite this in base 2 and then be able to figure it out pretty quickly without needing a calculator at all. So, helpful. But again, I know you guys already did this all on your warm-up earlier today, probably when you first woke up at like 6 a.m. is my guess. You're probably not lying on the couch or lying in bed right now. Almost definitely not. So for solving logarithmic equations, we have a couple methods that we're going to use. All right. Method 1 is that if we have the same base logarithm on both sides only. All right, so that's and I mean the only, like, it is the only thing that is on either side. It's just on the right side there's a logarithm with some base, and then on the left side the only thing there is a logarithm with some base. But make sure on both sides it's the same base. So that's our first. If this happens, then what we're going to do is, if it would let me write, we're going to ignore the logs and just solve what's inside them. Okay, we'll just take the inside of the logarithm, set it equal to the inside of the other logarithm, and we'll just solve. Right? So when I write out these methods, it probably won't make a ton of sense of, wait, what does this actually look like? But we're about to do some examples that'll illustrate it. But this is just kind of the brief description. Okay. Method 2 is we will use log properties in order to transform our equation into a method 1 equation. All right, so it doesn't, I look at an equation, it doesn't quite look like where it's just a logarithm on one side and just a logarithm on the other side. There's some more stuff of some kind. And so there's probably multiple logarithms, right? So I'll try to maybe combine some logarithms together. That way that I just have like a logarithm equals a logarithm. Right? And then we'll use the same process in method 1. Once we get there, just solve, set them equal and solve. And method 3. So this will happen if there is only one logarithm in the whole equation. There's definitely not logarithms on both sides. There's definitely not multiple logarithms on either side. There's literally, I can only find one logarithm in the entire equation on either side total. So if that happens, then we're going to isolate that logarithm. And then we'll use exponentials to solve them. So we'll get the logarithm by itself, and then we know that the inverse of logarithms are exponentials. They're inverses of each other. So if I want to get rid of a logarithm, I use an exponential. So that's what we're going to do so that we can close it out and solve for whatever we actually need. All right. So first example, log base 9 of 3x minus 5 equals log base 9 of 15. So I would kind of run some diagnostic when I first look at an equation and decide, wait, what method should I be using here? Well, I'm looking and I'm seeing that I have a logarithm, just a logarithm on the left side, just a logarithm on the right side. They're the same base. They're both base 9. So in this instance, this is a method 1 equation. And so what that means is we can disregard the logarithm and just look at this inside stuff instead. So 3x minus 5 equals 15. Because if the outsides are the same, it's just log base 9 and log base 9, and the two sides have to be equal, well, then it must be that the insides of those need to be the same as well. So we'll just set them equal to each other. 3x minus 5 equals 15. 3x equals 20. X equals 20 thirds. So this method is kind of what we always hope for, probably because it's the easiest, is, oh, hey, the logarithms equals the logarithm. Well, then who cares about the logarithms? Let's just set the stuff inside equal and get it done. All right, next up. Log base 4 of 12 minus log base 4 of 5x equals 3 log base 4 of 5. Okay, so this is definitely not a method 1 equation because, first off, I have more stuff, right? For example, I have this coefficient of 3, right? Besides the stuff inside the logarithm. So I have a coefficient of 3 over here. All right. And on the left side, I have some logarithm minus another logarithm. So this is certainly not just log equals log. This is log minus a log equals 3 times a log. Right? That's a lot more. So what we're going to do, so this is a method 2 equation. Definitely not method 3, because remember, method 3 is if there's only one single logarithm in the whole equation. So this is not method 3. It's not method 1, so it must be method 2, where I need to use my logarithm properties so that I can transform and manipulate stuff so that it looks like a method 1 equation. Right. On the right side here, I'm trying to think, what can I do with this coefficient? Now, your first guess might be to like, well, let's divide 3. So that's true. That would get rid of the 3 on the right side. But then now on the left side, I have all this stuff divided by 3. And that doesn't really help me out anymore either. Okay. So instead, I'm going to use my logarithm properties that I can remember. Oh, a coefficient of 3, I can move up into the exponent inside the logarithm. Right? That was one of our properties that we just talked about yesterday and in the warm-up even. On the left side, logarithm minus logarithm, and they're the same base. So again, remember another property. If two logarithms are being subtracted and they're the same base, we can combine them together. We can condense them into one logarithm using division. First logarithm, or what's inside the first logarithm goes into the numerator. What's inside the second logarithm goes into the denominator. And so now, just by using a couple short properties, I've now transformed this into a method 1 equation. Just log on the left side, just log on the right side, and they're the same base. There's no coefficients, there's no plus or minus anything else on the outside of it. It's just log base 4 equals log base 4. Great. Because if that happens, then that means I can just focus on whatever's inside those two logarithms and set them equal to each other to solve. Five cubed, 125. So I'll go ahead and do that. So we need to solve. We will multiply 5x on both sides. 5 times 125, 625x. Divide by 625. So 12 625ths. Oh my gosh. Another call. Are you guys seeing this? This is, I mean, again, not, of course it's normal for me to be getting just calls upon calls. You know, I get it. People miss me, and totally normal. So luckily I turned it on silence this time. And a voicemail even. These people are desperate to get a hold of me. They're leaving voicemails. You know, you know, I feel bad, but I gotta put my students first, and that's you guys, I think. Maybe. I guess I don't really know who's watching. So method 2, use some properties, change it up until it looks like a method 1. And then lastly, so negative 5 plus 3 log 2 of 7x plus 1 equals 13. And so run through the checklist. Definitely not method 1, because it's not just log equals log. Definitely not method 2, because method 2 requires me to still have more than one logarithm, so that I could have one on either side if I transform it. So this is method 3, where I see that there is only one single logarithm in this entire equation. All right, great. So actually, I'll highlight. All right, this is the logarithm that I care about right now. All the other stuff is excess, and it's, well, I guess not excess, but it's extra stuff that I want to move away. All right, so when I say isolate the logarithm, anything that's not in that highlighted region, I want to get rid of to move to the other side. All right, so I want to get rid of that -5. I want to get rid of that 3 that's being multiplied so that I just have log base 2 of whatever's inside of it, in this case 7x plus 1. So add 5 to both sides first, and then divide 3. So now to solve this, I have this log base 2, and I want to get rid of the log base 2. Well, to get rid of logarithm, we have to use exponential. That's its inverse. So what I'm going to do is this. So I'm going to write this out first, and then I'll explain. So I created an exponential on both sides. 6, yes, sorry. Thank you. Yeah, so I created an exponential where whatever was in the original equation now gets moved up into an exponent. All right, so what I introduced was those red 2's on either side, because like always, if we do something to one side of an equation, we're fine as long as we do that same thing to the other side of the equation. All right, so everything just got bumped up. I do that because exponentials, logarithms, inverses. So when I have the 2 to the power of log base 2, they cancel each other out to just leave me with 7x plus 1 equals 2 to the 6th power. 2 to the 6th power, I think is 64, right? Maybe? Yeah. Right, but we had to use those 2's, the base 2's of the exponential, to get rid of the logarithm. So now it's just a basic two-step equation. 7x plus 1 equals 64. Subtract 1 from both sides, 63. Divide by 7. X equals 9. So get the logarithm alone, isolate it, use exponential. So in this case, that red step of adding the 2's, the base 2's. Okay, let's try one more here. So looking at this, I recognize this is another method 3 because there's only one single logarithm in the entire equation. And that logarithm is this. Right? Notice that I'm not including the -4. Right? The -4 is a coefficient of the logarithm, but it's not actually part of the logarithm itself. So when I say isolate the logarithm, I mean we need to get this highlighted portion alone, isolated. So I'm going to have to move that 5. I'm going to have to move that -4 so that just this highlighted portion is alone. So first step, I'm going to subtract 5 from both sides. So equals negative 16. This is a step where I actually tend to see a ton of mistakes because I think a lot of times when people just kind of going too quick, you see the negative 4 and then think, oh, add 4 to both sides. But we don't want to add 4 to both sides because think about what's happening between the negative 4 and the logarithm. They're being multiplied. So I actually want to divide both sides by negative 4. Negative 16 divided by negative 4 is 4. And now we're at the same part where we were last time, where it's like, okay, great, I isolated the logarithm, but now I need to get rid of the logarithm, right? So we have to use exponential. In order to know what base we should use, I look at the base of the logarithm. So since it is 3, I will use 3. So I'll make that base of 3 on both sides. And everything else just goes up into the exponent. Exponential base 3, logarithm base 3, they cancel. It's 3 to the 4th power. What is that, 343? Oh, 81, yeah. I think I went one more. Yeah. 5th power would be 243. But 3 to the 4th power, 81. And then we solve. Subtract 5 from both sides. 76. Divide both sides by 2. 38. And that's my last problem. So, anybody have any questions for me? No. So, like I said yesterday, I'm not gonna have you guys email me like every homework assignment that I send you. So I sent you a homework assignment today. It's just for your own practice to complete. I'm at least right now, I don't plan on checking it or looking through pictures of the homework that you did. Maybe every now and then, like maybe every couple of weeks, I'll do that for an assignment or something. But in general, no. But I'll tell you if there's something specific that I want you to send me. I'll tell you on here, and I'll put it in the email too. But otherwise, just practice on your own since you got nothing else to do. Could you possibly send out a key for today's homework later? Yeah, I think I could do that. Yeah, I could do that. Are you gonna stream Overwatch later? Yeah, at 2 a.m. again. Join us on Minecraft. Yeah, I'll be right there. It's a Bowtie Minecraft server, correct? How many followers? I'm at 51 right now. No, 52. So I'm well on my way to success here. Now, how many of these are actually my students? I do not know. But I would say a good portion are not actually my students. Have you guys had to do a lot of stuff on like Schoology and like video conferences with other classes or anything? I don't know. I don't know what other teachers are doing. Except I keep hearing that Schoology keeps being down at random points or for some people. So I don't know. I'm glad I'm not doing Schoology. I'm doing this instead. Only one conference, not a lot of stuff. Just set goals. Yeah. Yeah, true. Yeah, just make sure you're they honestly are tracking what you guys are doing, what you're logging into, and like goal setting. You know, from home, we don't we don't have a lot of metrics we can measure that for like school stuff you guys are doing. So the things that they can measure is: are you logging into Schoology? Are you logging into Summit? Are you setting goals? So make your own life easier so that nobody, you know, emails you or calls your parents, whatever, and says, "Hey, we're not sure that they're doing school stuff still." So, you know, log into your stuff, make some Summit goals, whatever. It's fine.